Sorry, sir, I'm late.
Okay, no problem, Surita. Hello. Okay, so let's start chapter number 3, that is motion straight line. First of all, what do you mean by mechanics? Mechanics is the branch of physics which deals with two different parts. You can say study of body at rest or motion is called mechanics. So in this part, first is study of rest and second is study of motion. Study of rest is also called statics and study of motion is also called dynamics. In statics, you will simply learn study of an object due to its interaction and it will remain at rest or in equilibrium is called statics. Next is study of a body which is in motion. So we mainly divide this particular dynamics into two parts. First, consequences of motion, and second, causes of motion. Let me define you what these two different terms would mean. Suppose if you have a body and you have applied some external force, work done, momentum, so that this body will move along this direction to cover some distance, displacement, speed, velocity, acceleration. So these terms, distance, displacement, velocity, acceleration, are called as result or impact of that particular motion. But these terms, force, work, linear momentum, and so on, these will cause motion to this particular object. So you can say these are causes of motion. So causes of motion such as force, momentum, work, energy, consequences of motion, or you can say result or impact of that particular motion. So in this, you will study distance, displacement, velocity, acceleration, and so on. So this entire path, that is consequences of motion, is called as or termed as kinematics. And this entire path, that is causes of motion, is called as proper dynamics. So your chapter number 3 and chapter number 4 mainly deal with just kinematics and one dimension. And so the whole chapter, whole your 11th class will define you nothing but proper dynamics. Is it clear to you all till this part?
Yes, sir.
Okay, just write it down.
Done, sir.
Written. Mr. Vidan, so when we start with this, that is kinematics. Kinematics derived from a Latin word which is called kinema, or you can simply say it as cinema. Kinema simply defines you motion of a particular object or consequences of an object without considering its causes is called kinematics or kinema. So simply kinematics defines you the study of result of motion in a body without considering its cause is called kinematics. Now, we mainly divide this particular kinematics into two parts. First is called uniform motion, second is called non-uniform motion. Uniform motion means a motion in which acceleration of body would be zero. So body would cover equal distances in equal time gap. Then this type of motion is called uniform motion. Next, non-uniform motion. If a body covers unequal distances in equal time gap is called non-uniform motion. So in this part, acceleration would not be equal to zero. Now we further divide this particular non-uniform motion into two parts depending upon acceleration having constant value or it would have some variable term. So if acceleration is constant having some fixed number, so we can call it as uniformly accelerated motion. And if acceleration is variable, or you can say time dependent or position dependent function, so we can call it as non-uniformly accelerated motion, non-uniformly accelerated motion. Now, divide this uniform motion into two parts, depending upon you are considering its horizontal path motion or you are considering vertical path motion. Am I audible properly to you all? I think there's some disturbance.
Yes, sir.
Okay. So we mainly divide this particular motion or kinematics into two parts, depending upon acceleration is zero or acceleration is not zero. So if acceleration be zero, it means it is called uniform motion. So we mainly define in this part distance, displacement, speed, average speed, and velocity only in this section. So let's say this is your first section. Next is if acceleration is non-zero, so it will have two different values. First, if it will be some constant number, 2, 5, 7, -1, -7, and so on. So it is called uniformly accelerated or uniformly decelerated or uniformly retarded motion depending upon sign of acceleration. If it would be positive, then we call it as acceleration. If it would be negative, you can call it as retarded motion. So this particular accelerated motion may be further divided into two parts, whether you are considering along horizontal path and whether you are considering along vertical path. This particular vertical motion is also called free fall or motion under gravity. Motion under gravity. Now, the next part is if acceleration is variable, you can say it is non-uniformly accelerated motion. It means acceleration would have some time-dependent, position-dependent function. With respect to this part, you would be able to calculate velocity, speed, displacement, and so on. So how to approach this whole problem? So we mainly divide this entire path into four different categories. First is called uniform motion. Second is called uniformly accelerated motion along horizontal path. Third is called uniformly accelerated motion along vertical path, or you can call it as free fall or motion with gravity. And then next, it is called non-uniformly accelerated motion, or it would have time-dependent or position-dependent function for velocity, displacement, and acceleration. Is it clear to you all?
Yes, sir.
Okay, just
Yes,
write it
sir.
down and just write it down. Just write it down. Coming 1 minute. Have you all done till this part?
Yes, sir.
Sabita?
Yes, sir.
Yes, sir.
Okay. So first is called uniform motion. Body covers equal distances in equal time gap, that is called uniform motion. If body covers equal distances in equal time gap. In this part, the first term is to define what do you mean by distance and displacement. Yusra, would you like to explain this two term? Mariam, what do you mean by these two terms, distance and displacement?
Sir, distance is the length of the path covered by an object in a particular interval of time. Distance is total length, and displacement is
Is it
the short
mandatory
rate.
to particular interval time? Okay, okay, good.
No.
Let's say if you allow to draw this particular insect on the surface, it will move like this from this point to this point. Let's say this is A and this is B. So distance is nothing but the actual path covered by this particular body from going from one point to another. So distance is nothing but actual path covered by the body from going from one point to another is called distance. And displacement is nothing but shortest path between its initial and final point. So you could say shortest path between initial and final point is called displacement. Now, you may further distinguish in these two segments as, for distance, if you move from A, it will be like this, and so on. Then this part, for calculating actual path length of this particular entire path, direction of body would be changing at this point, this point, this point, this point, and so on. So you'd say direction is not fixed. Or you'd say no fixed direction. But for this part, displacement, there's only one path for which displacement or the path length will be shortest. So you can say it would have fixed direction between initial to final to cover the shortest path. Next, these two segments are nothing but length or path length covered by the body. So it will be measured in terms of meter. So it's SI unit meter. And for this also, is it clear your till this part?
Yes, sir.
Yes, sir.
Just write it down. I'm giving one problem regarding this. Have you all done to this part?
Yes, sir.
On this basis, just try to simplify it. A boy goes 8 meter east, then 4 meter north, then 2 meter west, and then 1 meter height and displacement try to simplify it.
Sir, 4 meter north, and then
8 meter east, 4 meter north, then 2 meter west, and 1 meter south. 2 meter west and 1 meter south.
हाँ अजान हो रही है।
Sabita, have you calculated distance and displacement for this part? They help you. First of all, for this type of problem, try to define or draw graph or diagram related to this part. Let's say for first, it covers 8 meter distance along east. So it will be 8 meter along east like this. Then it will move, it will go 4 meter towards north, and then 2 meters towards west, and last 1 meter towards south. So this will be actual diagram for this path. Is it clear, Sabita?
Yes, sir.
Now, how to calculate displacement? Just draw starting point to its final point. So this will be your shortest path. Draw a perpendicular from this. Here we have 8 meters from this point to this point. And here we have 2 meters from this point to this point. So 8 minus 2 will become 6 meters from this point to this point. Is it clear, Mariam?
Yes, sir.
Similarly, you have this particular length as 4 meters and this particular length as 1 meter. So you get 4 minus 1, 3 meters from this point to this point. Now we have a triangle which having base as 6 meters and perpendicular as 3 meters. So you will get this shortest path, which is nothing but hypotenuse of this triangle. Just use Pythagoras theorem, you get displacement. Is it clear?
Yes, sir.
Try
Yes,
to
sir.
solve.
Sir, can you please explain it once more because I got disconnected?
Okay. A ball covers 8 meters east. So let's say you have origin at this point, and this is along east, north, west, and south. So he's going 8 meters along east. So this particular length from this point to this point is 8 meters. Now from this point, he's going along north to 4 meters. And from this, he's going along west to 2 meters. And from this, is going 1 meter south. So this will be your actual path. Now, how to calculate displacement? You have to draw origin to that fine point as the shortest path. So I have just drawn this. And to get the value of perpendicular and base, I further extend this length to this part. Now you got a triangle. This particular length from this point to this point is 8 meters and this length is 2 meters. So if you subtract these two terms, you will get this length or this base of triangle as 6 meters. Similarly, you have 4 meters along this path and 1 meter along this path. So if you subtract these two terms, you will get 3 meters from this point to this point. Is it clear now?
Yes, sir.
So distance of this particular path would be actual path covered by the body, 8, 4, 2, 1, and it would be 15 meters. For calculation of displacement, you have to calculate hypotenuse of this particular triangle, which according to Pythagoras theorem would be equals to base squared perpendicular squared. 6 square is 36 and square root of 3 is 9. So it will be the root of 45, or you can write it as 3 root 5 meters. Good, Savita. Is it clear, Mariam?
Yes, sir.
We are done with this part.
Yes, sir.
Yusra,
Yes, sir.
after knowing distance and displacement, the next part is to define speed. Speed is nothing but if a body covers a particular distance, then if you have to calculate at what rate the distance is covered by that particular body. This physical quantity is termed as speed. So speed is nothing but the rate at which distance is being covered by a body. Or you would say speed is simply equals to distance covered divided by time taken. I'm defining you a triangle to define relationship between these three segments. Let's say if you have distance, speed, and time. Now, if you have to calculate speed, just cover this up, you'll get distance over time. If you have to calculate distance, just cover this, you'll get speed into time. And if you have to calculate time, just cover this, you'll get distance upon speed. So on knowing this particular triangle, you will get easily all of these three terms. Is it clear?
Yes, sir.
Yes, sir.
So first is speed is nothing but distance traveled by time taken. Now the most important part of this term is to define average speed. Let's say if you have a journey from this point to this point, which would have some interval. Let's say A, B, C, D, and so on. So the distance between A to B is x1, x2, x3. Time taken is t1, t2, t3. And speed of object for AB is b1, BC is b2, and CD is b3. I'm just considering between each interval, distance, speed, and time, all of these three different terms. So average speed is nothing but the total distance covered by the body in total time taken for the entire journey. So it is nothing but ratio of total distance covered by the body in total time taken to covering that journey. So it is nothing but the ratio of total distance covered by body in total time taken. So average speed is equals to total distance covered by total time taken. Total distance covered is x1, x2, and so on to xn. Divide by total time taken is t1 plus t2 plus so on to tn. So this will be a formula to calculate average speed. Is it clear to you all to this part?
Yes,
Yes,
sir.
sir.
Okay, just write it down.
Done, sir.
Done, sir.
Have you done? Now, we have certain special condition for this part. First, if time interval for covering that distance are equal. Let's say T1, T2, and so on to Tn are all equal to T. So if you put this value in that equation, you will get average speed is total distance covered by the body. So x1 would be written as v1 into t, x2 would be written as v2 into t, and so on to vn into t, divided by time taken t1, t2, and so on to tn. So if you take out t as common from numerator, t dt to n times will give you n times t. So on simplifying, you will get v1 plus v2 so on to vn divided by n. This is nothing but mean or average value of all individual speed. So you'd say if time gap for covering that each interval are equal, then average speed can be calculated by arithmetic mean of all individual speed. So it is nothing but arithmetic mean of all individual speeds. Finally, one more term regarding this. Path length covered by the body are equal. Let's say x1, x, and so on to xn. These all intervals are equal to x. Convert time is equals to distance by speed. So t1 is x1 over v1. Similarly, t2 is equals to x2 over v2, and so on to tn is equals to x over vn. Now put this value in the first equation of average speed. So it would be total distance covered by the body, x1 plus x2 plus so on to xn, and the whole divided by t1, which is nothing but x by v1, t2, which is nothing but x over v2, and so on to tn, which is x over v. Now, this whole term in numerator will define you n times of x. And if you take out x as common from both these denominator, you will get n divided by 1 over v1, 1 over v2, and so on to 1 over vn. So this whole term is nothing but termed as harmonic mean of individual speed. So you would say harmonic speed, harmonic mean of all individual speed. So I've just concluded three different expressions to get average speed. In first part, if there is no relationship between time and distance, so it will be total distance traveled by the body into time taken. So it will be x1 plus x2 plus so on to xn divided by t1 plus t2 plus so on to tn. But if there is some special condition, like if you have equal time gap, so this formula will transform to this. So you will get average speed by taking arithmetic mean or just average value of all individual speeds. Similarly, in the next part, if all of the path length covered during the entire journey are equal, let's say x1, x2, and so on to xn are equal, so average speed can be calculated by using this formula, and this will be nothing but harmonic mean of all individual speed. So from this you will say we have maybe three different special conditions to get average speed. Is it clear, Sabita?
Yes, sir.
Yusra?
Yes, sir.
Okay, just write it down. I'm giving you some problem regarding this, and you have to analyze which property would use in those problems.
Done, sir.
Done, sir.
Man goes to market at 6 meters per second and return back at 3 meters per second. Find average speed for the journey. I'm giving you some hint. Let's say to market. So on going from home to market, so you say distance from home to market and distance from Yusra, what do you conclude about the distance on going from home to market or market to home? Are they equal or unequal?
Unequal.
Means on going from home to market.
Okay, no. Distance is equal.
As the interval going from home to market are same, so you'd say distance on going in either different direction or either both path would be equals to 6 meter per second and V2 is equals to 3 meter per second, and in this part x1 is equals to x2. So just use the formula n divided by 1 over v1, 1 over v2, and so on to 1 over vn. In this part, we have just two intervals. So put n is equals to 2, v1 is equals to 6, and v2 is equals to 2, and try to simplify it. Is it clear, Savita?
Yes, sir. Sir,
Yes.
sir, could you once again explain how the distance is equal?
On going from home to market and on returning back, path on going from this to this and this to this would be same. So distance would be same.
Yes, sir. Thank you, sir.
That's why I've taken x1 x equals to x2. It would be meter per second. Good, Mariam. So, Bita, just check your calculation. Yusra. Good, Yusra. Try to solve one more problem. Car travels at 12 meters per second and 4 meters per second equal time gap. Find average speed. Try to solve. In this problem, we have two different velocity v1 and v2. Car is traveling for equal time gap. Just use the second formula. You get your answer. Yusra, problem while solving this? In this part, you have equal time gap. So use the second formula. Then and in this question, we have only two intervals. So you use S. V1 is 12. Yes, Sabita, you're right. 4 is 16. Divided by 2 is 8 meter per second. Is it clear, Isra?
Yes, sir.
Now, next part is to define velocity. As speed depends upon distance, the rate at which distance is covered by a body. Similarly, velocity is defined as rate at which displacement is being covered by any body, or you would say the rate of change of displacement is called velocity. So velocity is simply displacement over time taken. As displacement is a vector quantity and divided by time, which is scalar, so velocity would be a vector quantity. So how to define displacement for any interval? Let's say if a body is going along circular path from this point to this point, A to B. Radius of this particular path is suppose 10 centimeter, and it's going along this path from A to B. If takes 5 seconds to move from A to B, lost it. So first of all, you have to calculate displacement from A to B. And as we know, displacement is nothing but the shortest path between A and B. So just draw the shortest path from this point to this point. Is it clear? So in this
Yes, sir.
triangle, you would have this as radius and this as radius, and both are perpendicular to each other. So using Pythagoras theorem, you will solve for this AB. So AB would be equals to root under base square perpendicular square. On solving, you will get root 2 times of r. As r in this part is just 10 centimeters, so convert it to meter. 10 divided by 100 root 2. This 0 and this 0 would cancel out. So you get root divided by 10 meter as displacement from A to B. Now to define which is nothing but displacement over time, just put all the values and you'll get the answer. So if you put the value of displacement behind this part, you will get root 2 divided by 10 for displacement and whole divided by time taken, that is 5, which would be root 2 divided by 50 meter per second as velocity of the body. Clear to you all?
Yes, sir.
Yes, sir.
Now to define this velocity or average velocity, it would be more complicated or twisting, I think, in second unit, that is in fourth chapter, which is in vector. Till now, you have to use only this formula. Okay, so this is all about uniform motion for body covers equal distances and equal time gap. Now the next part is uniformly accelerated motion. So first of all, what do you mean by acceleration? Acceleration is nothing but rate at which velocity is being changed, or change of velocity with respect to time, or you would say the rate of change of velocity is called acceleration. So A is equals to change in velocity divided by time. Depending upon change of velocity, you will have two different values. Let's say u has initial velocity say u is initial velocity, means velocity of body at t is equals to 0, or a starting velocity. Velocity of body at t is equals to 0, or starting velocity. V is final velocity, or you would say velocity at any final instant of time, or any particular instant of time. Now, if you put these two values in this part, you will get V minus U divided by time taken is equals to. Now, depending upon these two values, you will get two different parts. First, if final velocity is greater than initial velocity, so A would be positive. If final velocity is less than initial velocity, you would get A as negative. So for A is positive, this is called acceleration. And if A is negative, this is called deceleration or retardation. Now, if you further simplify it, you will get equation of motion to solve this. Is it clear till this part?
Yes,
Yes,
sir.
sir.
Just write it down. I'm defining the equation of motion and how to approach any problem. So, Beta, have you written?
Done, sir. Done, sir.
Done, sir.
Now, to define this whole part or uniformly accelerated motion, you have to use equation of motion. Now I'm defining the relationship. First is du means final velocity and initial velocity and t is time. Relation would be constant for all of this entire different four equations. The first equation will be termed as velocity time relation. So you have to calculate velocity or time. So you have to use this first equation. Similarly, u, which is initial velocity, most of the problem it will be zero. So you will left with s, which is displacement, and t in this part. So this is termed as displacement time relation. Third is velocity, velocity and displacement. So it will be velocity displacement relation. And last is SNN, termed as displacement covered by body in nth second. I'm defining you relation between this equation and this whole these three different equations. These three different equations were based on period of interval. It means from starting of journey till that given time interval. Let's say if you have path interval like this. This is your starting point t is equal to 0, 1, 2, 3, 4, 5, and so on to some nth time. So first second, second, third second, fourth second, so on. Let's say this part is some n minus 1 interval and this part has some n interval. So if you have to use any of these three equations, it will be based on from starting of the journey to that particular point. From starting of the journey till that given point of time. Suppose if you have to calculate displacement of body using this equation, it will define you displacement from starting of the journey till that given point of time. So we can call it as period of time, or it will define distance traveled by the body from starting of the journey till that given time interval. So distance traveled by body from starting till that time. Or if you have to calculate velocity, so it will be velocity also. Now, how to define this fourth equation? Let's say if I ask you to define this interval, it will be nothing but displacement from 0 to 1 second, or you can call it as first. Similarly, from this 1 second to this 2 second will be termed as second. Similarly, from this part to this part, it will be termed as third second. Just in this interval, defining for any two consecutive time gap from 1 to 2, from 2 to 3, from 4 to 5, and similarly from n minus 1 to nth interval. This interval is termed as nth second. So in this part, it is defining nothing but between two consecutive interval gap. So we can call it as point of time, or you'll say distance covered between two consecutive time interval. So for this part, you use SN. Is it clear, Yusra? Maria,
Yes,
any
sir.
doubt till this part?
No, sir.
Okay, just write it down. I'm giving you some problem and defining how to solve it.
Sir, what value of the second formula is usually 0?
Yes, Mariam?
Sir, what value of the second formula is usually 0?
Initial velocity. For most of the case, if body is starting from rest, take initial velocity u to be 0, and this whole part would be 0. So you'll get s versus t relationship.
Done, sir.
Done, sir.
Assumptions to define this part. Body starting from rest. So u would be 0. Body finally stops. So v would be 0. And if a body is going or traveling at uniform motion, so acceleration would be 0. So v would be equal to 0. Now, using these three assumptions, you have to solve first acceleration for each part, and then you apply formula regarding it. Body starting from rest, accelerates uniformly and covers meter in 4 seconds. Find first acceleration, second velocity at 5 seconds, and third distance traveled in third second. Just in this part, we have body starting from rest. So you'd say its initial velocity would be 0. Covering 8 meter in 4 seconds. So it means S is 8 and T is 4 seconds. So just use the second equation of motion, you'll get acceleration of that particular object. On calculating acceleration, using first equation of motion, you calculate velocity at t is equal to 5 seconds. And similarly, using fourth equation of motion, you will calculate this part. Is it clear?
Yes, sir.
Try to solve acceleration from using second equation of motion and then apply the rest of the part. Sabita, is it clear?
Yes, sir.
Good, Sabita. Madam, should I solve? Sabita, just check your calculation. Suppose in this part you have initial velocity is 0, is 8 meter per area, and time initially is 4 seconds. So using this part, just use second equation of motion, half it is square, on put you will get A is equals to 1 meter per second square. Now again, for second part, we have T is 5 seconds. So apply for equation of motion, use T is equals to 5 seconds. Using first equation of motion, B plus 18. Use 0, acceleration is 1 and T is 5. So on solving, you will get just use fourth equation and put the value of n to be 3. You'll get your answer of distance traveled in third second. Good again. Sn is u plus a over 2 times 2n minus 1. U is initial velocity, which is 0 in this part. A is 1 divided by 2. 2n. N is just 5. N is 3. So it would be this part. 2 into 3, 6, minus 1, 5, divided by 2. So it will be just 2.5. Is it clear, Sabita?
Yes, sir.
Yusra, do you have any doubt in this whole part? Or should I explain it once again? Yusra, any doubt till this part? I'm giving you one more problem regarding this. A body moving at 4 meter per second accelerates uniformly at 2 meter per second square. Then find first distance traveled in second. And find law of body in 5 seconds. Just use the and try to simplify it.
Sir, moving at 4 meter per second is taken as initial velocity, right?
Yeah.
Okay, sir.
So this will be your initial velocity u, and this will be your acceleration a. So in first problem, we have to calculate in fifth second. It means it is defining you point of time or distance for consecutive seconds. Use fourth equation motion and based on n put it equals to 5. Second question, you have to apply second. Okay, Sabita?
Okay, sir.
No, you just check your calculation. So this part, u plus a over 2 times n minus 1. U is nothing but 4, just to push it here. A is nothing but 2, so it will divide by 2. 2 times of n is just 5, okay? Minus 1. 2 into 5, 10, minus 1, 9. So you get 4 plus 2 and 2 would cancel out, so it would be 1 into 2 into 5, 10, minus 1, 9. So 9 into 1, 9 plus 4, it will give you 13 meter. Is it clear, Maria?
Yes, sir. I was taking 1 by 2 instead.
Okay, okay. In this part, we have acceleration as 2 meter per second. Try to solve second and third. Third is correct. Rita, your answer is correct. Good, Mariam. So use S is equals to UT plus half AT square. Use initial velocity, which is 4 is 5 seconds, plus half acceleration is 2, and time taken is just 5 squared. So 2 and this 2 will cancel out. So you'll get 4 into 5, 20, and square of 5 is 25. In total, it will define you 45 meter. Using third equation of motion, and the first equation of motion, you'll calculate the third part, which is u plus 80. U is 4, A is 2, and time is 5. So it will be just 14 meter per second. Yusra, do you have any doubt till this part?
No, sir.
Have you written this whole part?
Yes, sir.
Yes, sir.
I'm defining you one application regarding this. There is a concept of reaction time. I think you all have learned in biology about stimulus and response, I think in class 9 or 10. I don't know. Let's say any surrounding change which will cause to change in your body in response of that. So the total time taken for this entire segment is called, suppose if a pen get injected into your skin, so it will be just perceived by your receptors present on the tip of the skin, and message will forward to spinal cord and it will reach to the central nervous system, or it will be to the spinal cord. And for that particular action, it will be get responded by muscle cells to remove your hand. So the total time interval for this entire process is called the reaction time. So reaction time depends upon quickness or ability or different behavior of particular individual. And it would may vary from person to person depending upon his activity. So let's say if a driver is driving a car with some initial velocity u, and there is an individual in front of him at some distance from this point to this point. So on seeing this particular individual, the driver have to respond by applying brakes so that to get stopped after covering that particular some small distance. So the total time interval on visualizing or seeing that particular individual and getting responded by applying brake is called reaction time. So reaction time is nothing but the total time taken between stimulus and response against it by any observer or individual. So it would be time duration between stimulus and response against it by an individual is called reaction time. During this reaction time, this particular car will move with the same velocity as it was initially moving. So it must move with the same velocity and will reach to this point. So the total distance traveled from this point to this point, S R is equals to U times TR, as during this particular interval, there will be no acceleration or deceleration in this particular car. So A would be 0. Using second equation of motion, S is equals to ut plus half t square, in which A is 0. So you'll get S is equals to u into t. SR is distance traveled by the body during reaction time, and TR is nothing but time of reaction for that particular driver. Is it clear?
Yes, sir.
Now, in response, the driver would apply brake, which was initially moving at some velocity u. So, on applying brakes, this particular car would get retarded by some acceleration or retardation A. So, this particular term as taken as retarded motion. Let's say its retardation is A. So this car would stop completely, let's say to this point. So in this interval from this point to this point, we have initial velocity and the car is finally stopping at this particular point. So you would say its final velocity would be 0. So using third equation of motion would be v square u square minus of 2 times of a into s, as a is retarded motion. So you can take a to the negative. V would be 0 as car is finally stopping. So on solving, you will get s is equals to u square over 2 times of a. This particular distance traveled by this car to get stopped is called stopping distance. So you can write it as ST. So this will be your stopping distance, and this will be your distance traveled in reaction. Is it clear to this part?
Yes, sir.
Yes, sir.
Sabita, any doubt?
No, sir.
Just write it down. I'm giving you one problem related to this. This is your reaction time. This is your initial velocity. So first of all, convert this term into meter per second. So how to convert it? Multiply kilometer per hour by 5 by 18. You will get your speed in terms of meter per second. Here we have retardation as 2 meter per second square or A. So you will get U is equals to 20 meter per second. Reaction time is 0.5 seconds and A is just 2 meter per second squared. Just put all these values in these two intervals and you get distance traveled in reaction time and distance traveled in stopping distance. Put all these values in the above equation, you get SR and stopping distance. Should I solve? SR is equals to U times TR. U is velocity, which is 20 meter per second here. TR is reaction time, having 0.5. On multiplying, you will get 10 meter as distance traveled in the reaction time. Similarly, if you put all these values for this particular stopping distance, you will get U square over 2 times of A. U is 20, so it will be 20 into 20. Divide by 2 times A, which is also 2. So on solving, you will get 100 meter. Is it clear?
Yes, sir.
Yes,
Savita?
sir.
Okay, so do you have any doubt in this whole part?
No, sir.
No, sir.
Okay, just revise this whole part and try to solve more and more problems regarding this equation of motion. Okay. So this is all about phase class. In next class, I will define you free fall and then next graph. Is it clear?
Yes, sir.
Yes, sir.
Thank you, sir.
Thank you.
So when
Bye,
is
sir.
the next physics class?
I think on Tuesday or it would be on Sunday as well.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.